Hi everyone, so today I will talk to you about my postdoc project that aims to reconstruct the metal fertility that is associated with the construction of the Eastern Pontide in the northeastern Turkey. So I'm doing this project under the supervision of Robert Moritz in University of Geneva, and I'm also working with several researchers from Turkey and also with geologists from the MTA. So to introduce you a bit about the philosophy of this work, first I would like to remind how a continental crust can get enriched enough to make metal deposits. So we have several processes that range from lithospheric scale to regional scale, and with time scales that range from billion years to hundreds of million years. And what you can see here on this first figure that there is a temporal evolution of the composition of the continental crust that is also induced by the change of tectonic style. So the tectonic style evolves from the Archean to nowadays from vertical to horizontal. And this is associated with a change in the continental crust composition that evolves from mafic to felsic. And there is a change in the abundance of metal in the continental crust through times associated with these changes. The next processes actually are associated with the Wilson cycle, and they are characterized by the mantle crust interaction during crustal growth that is associated with subduction processes and relaxation exhumation, where the metal migrate from subcontinental lithospheric mantle that are enriched through subduction, and they also migrate from the astenospheric depleted mantle. The next process I would like to talk to you today is about the crustal differentiation, and the metal migrate within the crust, for example, during collision or post-collisional events. So all these processes will lead to the genesis of fertile region, segments, or area in the continental crust. So what I would like to do during this project is to reconstruct how these fertile areas are made in the Eastern Pontide that constitutes the northeastern Turkish part of the Titian Belt. So the Eastern Pontide are made of successive subduction zones that collide from north to south. It's associated with successive oceanic closure with collisional events, and it's a fertile metallogenic environment where you can find numerous porphyry deposits, magmatic hydrothermal deposits, and the whole are placed in arc segments during major magmatic events. So we have two main events, the late Cretaceous and the early late Eocene. So if we have a look to this geological map that shows the geographic position and ages of the porphyry deposits in the Eastern Pontide, what we can see is that the late Cretaceous deposits are in the north, and the latest Paleocene to early late Eocene deposits are in the south. So the question is why most, if not all, porphyry deposits from the Eastern Pontide are only related to late Cretaceous and younger magmatism, whereas the whole belt records hundreds of million years of tectonomagmatic history. So we have several hypotheses to explain this. Either the older deposits existed but were not preserved, or the source of the magmatic system was not enriched enough in metals to provide a stock that is sufficient enough to allow a deposit to form. And the third hypothesis is whether the condition for extracting the metal from the source and for concentrating them within a deposit were met or not. So all these hypotheses are the ones that I will test during this project. And the methodology I will apply consists in coupling compilation of the published data that will allow to reconstruct the crustal history and the temporal evolution of mantle crust interaction and crustal differentiation. And I will add also new samples that will allow me to constrain the geographic distribution of the composition, age, and mantle crust contribution. And on this sample, I will apply a multi-method approach that aims to couple structure, wall rock geochemistry, petrography, uranium-lead, hafnium, oxygen isotopes, and trace elements of the earth cones. So all these new data will be reintegrated into the compilation in order to have the most complete and accurate compilation of mantle crust interaction and crustal differentiation during the whole evolution of the Eastern Pontides. So just to show you a few examples of compilation and sampling I've done. So this is a compilation of the geological information I got from compilation that includes Iran, Armenia, Georgia, and Turkey. What you can see here on this map is reported all the samples I collected from the literature. So I have almost 180 references, almost 4,000 samples, and over 10,000 lines in the compilation. And what you can see is we have a lot of information about rock geochemistry, about geochronology, but the radiogenic isotopes and affinity isotopes are a bit more rare. So we still need to have this kind of data to be integrated inside of the compilation in the literature. And the final slide I just would like to show you so that you have an idea about how the project will be conducted, is that I complemented the compilation with the sampling of magmatic rocks. They are all represented here, so they are located across almost all the Eastern Pontide, and what you can see is that they range in age from Carboniferous to Eocene. Some of them are still unknown in ages, but we aim to have a sampling that is as broad as possible in terms of geography, geology, and age. Thank you very much.